This is Atomic Energy. This is the force of 20th century man, a powerful force for destruction, a force that may be preventing a new world war. This, too, is atomic energy, harnessed by American scientific genius to benefit all mankind through dramatic new discoveries in industry and agriculture, biology and medicine. 10,000 scientists and engineers are at work to prove that atomic energy does not mean only the atomic bomb. The master-slave manipulator at the Argonne National Laboratory, for example, makes possible important industrial research. Behind glass and concrete walls 3 feet thick, the operator is protected as he removes from its lead-shielded cask a container with a dangerously radioactive metal inside. The manipulator imitates the human hands in grasping, lifting, moving, and turning objects. Here the container is placed below a saw. A switch is thrown, and the saw bites into the metal. Intently now, the scientist watches the end of the container drop off. Next, the slave hands remove the tube and carefully shake out the radioactive metal for testing. The manipulator grasps the hot material and, directed by the scientist, places it under a hardness tester. A dial records the intensity of pressure. A microscope attachment enables study for industrial purposes of the effects of radioactivity on the hardness of metals. Strictest security safeguards America's atomic secrets. Every person working on a nuclear research project is intensively screened by the Atomic Energy Commission's protective force. And in the rugged areas where even the versatile Jeep cannot travel, mounted patrols ring atomic energy sites. At Los Alamos, amidst the wild, picturesque mountains of New Mexico, horses are of great value. The mounted patrolmen, through the use of radio, are regularly in contact with Protective Force headquarters in Los Alamos. Should a call for help be received, reinforcements could be dispatched by land or air in a matter of seconds. Day and night they ride, alert against spies and saboteurs. Giant anti-aircraft guns protect the Hanford, Washington atomic energy plant. Manned by carefully trained GIs, they guard against attack from the skies. At Hanford, biologists study the effects of radioactivity on fish, since Columbia River water is pumped through the plant. To safeguard Washington's flourishing fish industry, 25,000 trout and salmon are hatched each year and exposed to water contaminated with radioactivity. This is only one example of precautions that go on endlessly. In this case, there is not enough radioactivity to harm the fish or persons eating them. Hanford biologists are conducting similar experiments on sheep, feeding them pellets with radioactive ingredients. The paths of these substances are traced through the sheep's body. These experiments could be of tremendous importance to biologists and doctors, increasing their understanding of the processes of human life. In the field of agriculture, an isotope hothouse has been built at the Argonne Laboratory. Radioactive forms of plants are grown and examined under controlled safety conditions. Here a study is made of radioactive drugs which have been taken from the harvested plants. These drugs, which must be handled with gloves under a protective hood, undergo special analysis to determine how they can be most effectively employed by doctors in medical research. At the Oak Ridge National Laboratory's Medical Division, radioactive liquids are used by Atomic Energy Commission doctors in the fight against cancer, one of the dread diseases of mankind. Shielded by lead bricks, this solution, gallium-72, is an important tool in cancer research. Here a patient at Oak Ridge drinks an atomic cocktail of radioactive iodine in solution and then is placed on an examination table. Next, a radiation counter with a pen attached is lowered into place. The radioactivity in the drink, which has settled in the patient's thyroid gland, puts the pen in motion, drawing a picture of the diseased area. light and dark pattern of the drawing reveals healthy and cancerous tissues, a milestone in cancer research. These are but a few of the countless peacetime uses of atomic energy. In the years ahead, the infinite power of the atom may provide the force to drive ships and planes, light our homes, and turn the wheels of American industry. And in the fields of agriculture, medicine, and biology, its future is unlimited. With the atomic bomb, American scientists unlocked the devastating might of the atom. Today, they are engaged in the task of releasing atomic energy slowly, gradually, in ways of lasting benefit to a world at peace in the atomic age.